Hello, this is the fourth part in a series of videos on how to expand polynomials. So I'm going to pick up where we left off again. So we were discussing this rule for the sum of two perfect cubes, which is a squared x squared minus abx plus b squared in parentheses times ax plus b would give us the sum of two perfect cubes. And we can see how this applies to our polynomial. A squared x squared can be seen as 16x squared, and negative negative abx can be seen in minus 12x, since that's negative minus 4 times 3 times x, and b squared is 9. So you probably need to memorize this rule because it can be very helpful when you're trying to expand this type of polynomial. I'm going to introduce its sister form really quickly, and that would be a squared x squared plus abx plus b squared multiplied by ax minus b. When you work this form through, it should give you the difference of two squares. So if we changed our polynomial up here into this form, we would in fact have 64 x cubed minus 27. This is a rule that you'll have to remember. It can come in very useful. Make sure you know these two rules. Sorry for my atrocious handwriting. That looks like a D. But yes, very important. I'm going to mark that. Alright, so now we are going to do an application problem. So let's read this. Jay works for a company that manufactures industrial-sized fish tanks for aquariums. One day, the Newport Aquarium, Newport spelled wrong, aquarium ordered a fish tank for its new orca exhibit. The tank was to be 6 inches thick to withstand the water pressure and any potential collisions by an orca. Dimensions of the base, excluding the glass, has to be 25x inches by 14x inches. Also, the tank has to be 8x inches tall. What is the area of the base of this tank? And the second part, the shipping company needs to know the total volume of the tank when it's filled with water. So that is the volume of the water and the glass. Write a polynomial to express this volume in terms of x. So this is asking us to apply all knowledge of expanding polynomials that we've learned so far. So here we have two diagrams. This one here represents the base of the tank, and this one represents one of the walls. So the first part of this problem, it says, what is the area of the base of this tank? So we would have to write a polynomial. So how do we find the area of the base? Well, the base in this case is a rectangle, so length times breadth. However, in this case, we aren't given any solid numbers. We are given a variable and a constant. Do you see where we are starting to apply polynomials here? Alright, so 6 times 2 is 12. So this side will be 25x plus 12, and this side will be 14x plus 12. in order to find the area, we then express it like this. 5x plus 12 multiplied by 14x plus 12. Alright, so this should remind you of the form that we did in the very first part of the video, which is ax plus b times cx plus d. In this case, we would FOIL. And that would give us 350x squared and then the outside 12 times 25, it's 300 plus 300x plus 168x, and finally plus 144. $350x squared plus 468x plus 144. Alright, so this would be the area of the base in inches. So we have answered the first part of the problem by expanding polynomials. Let us look at the second part of the problem. The shipping company needs to know what the total volume of the tank is when it is filled with water. So that's volume of the water and the glass together. Write a polynomial to express this volume in terms of x. In order to find the total volume, we would have to multiply the area of the base that we have just found by the height, which can be seen here in this diagram. That is 8x plus 6. So this form should be familiar also. It is ax squared plus bx plus c in parentheses multiplied by in parentheses dx plus e. And so let me write it out really quickly. Um, 8x plus 6. Alright, now that we have worked out this equation, this is what we have. 2,800x cubed plus 4,844x squared plus 3,960x plus 864 inches cubed. That is the area of this fish tank. This concludes the video of this video about expanding polynomials. Thanks for watching.